Alright, so we've hit Charles, Boyles, and Gay-Lussac. Alright, next thing to do is look at the combined gas law. Basically, all of those calculations that we've been doing, right, either temperature, pressure, or volume has remained constants. Right, but the combined gas law, none of those remain constant. All of them can change. Right, and so now we're going to look at pressure, volume, and temperature all together. Once again, make sure your temperature is constant. Also, as you're doing these, all right, if your pressure, you have given two pressures on both sides, make sure that they're the same unit, atmospheres and atmospheres, or kilopascals and kilopascals. If you're given volume, make sure they're both in milliliters or liters. If they're not, you got to convert them. Alright, so P1 V1 over T1 equals P2 V2 over T2. Combined gas law. We'll rewrite our equation down here. So it's P1 V1 over T1 is equal to P2 V2 over T2. Alright, a gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2.0 liters. If the temperature is raised to 80 degrees Celsius and the pressure increases to 440 kilopascals, what's the new volume? Alright, we've got a lot of stuff this time. So 110 kilopascals, that's our starting pressure. Okay, so we have 110 kPa times, alright, or it's at 30.0 degrees Celsius. We don't like it in Celsius. Let's change it over Kelvin, add 273 to it, and we get 303 Kelvin as our starting temperature. Okay, our starting temperature is going to be 303 Kelvin. Scroll back up and look at our problem. So it fills a flexible container with the initial, that's 1. All right, so V1 volume of 2.00 liters. So this should be 2.00 liters. Alright, is equal to, if the temperature is raised to 80 degrees Celsius. So we got 80 degrees, 80.0 degrees Celsius plus 273 is equal to 353 Kelvin. Alright, so our ending temperature is 353 Kelvin. And a pressure increased to 444 kilopascals, so 440 kilopascals. And we want to know our new volume. So we are trying to solve for V2. So here are all of our numbers placed in. Okay? So what I'm going to do is I'm just going to manipulate this equation to begin with, and then I'll put it all in my calculator. Alright, I want to get 353 over here, and I want to get 440 over here. So I need to multiply by 353 to get that over here, and divide by 440 on both sides. So I'm going to need to multiply by 353 Kelvin, and divide by 440 kPa. Those will cancel out all that fun stuff over there. I need to do the same on this side. So I'm going to be multiplying by 353 Kelvin, dividing by 440 kPa. Do it just like that. So I now have V2 equaling all of this. Let's put in our calculator 353 times 110 times 2.00 divided by 440. Make sure you put this in parentheses on bottom, times 303. You get the new volume of let's see, 5. Let's see how many sig figs we have. So, what does this 110 say? So that 110 only makes up 2 sig figs there. So 0.58. And what do we have left? Well, Kelvin cancels out, kPa cancels out, and we are left. Oops. Erase it quickly. We are left with liters. Right, 0.58 liters. And there's our answer, and that's how you do the combined gas law.